Hi guys! So, today we are going to talk about Python Decorators. Now, Python Decorator is one of my favorite topics, and there are two reasons for that. The first reason is that Python Decorator is an extremely useful tool for many programmers, and it is also very unique to Python language, so it's really worth knowing it. The second reason, is that deep understanding of how Python decorators work will actually provide you more deep understanding in how programming languages work in general. So it's a very nice bonus. Now, what are we gonna do today? So this video is the first video in a 4-part series about Python decorators. This video will provide you some basic knowledge about what a decorator is, how to use it, what is the syntax of decorators, and you will also write together with me a very simple Python decorator. Now, though this video will provide you with some basic knowledge about decorators, I highly encourage you to continue watching next videos, because in upcoming videos you will see more advanced examples of Python decorators. You will see more interesting decorators, we will write them together. And in the first video in the series, you will also see how to use a built-in property Python decorator, which is used among all the programmers, I think. So let's start. So let's start looking at our code and let's start understanding what decorator is. And in order to understand it better, I would like to start from a motivating example. So let's say I have a very nice Python module called various functions. And just like the name says, I have 4 nice functions defined in this module. The functions are really simple and they perform different operations for the user. So one of them is factorial and capitalizing name and converting a temperature from Fahrenheit or from Celsius. As you can see, I will just try and run one of these functions. For example, let's run the capitalize. So if I will try to run it, you will see that the function actually asks to enter some text. I will enter my name, and then it prints the result, which is the capitalized text. So as you can see, there are 4 functions in here, but think that it could be much more. And let's say that now I've got the following action to do. I want somehow to improve user experience of those who use my module. And each time they run any of these functions, I would like, first of all, to print some welcome message. And then I would like to run the function itself. And then I would like that in the end, my function will print them some nice goodbye message and thanks for using our service, or something like that. Now, I want this to happen for all the functions in my module. And the simplest way to implement this would be, of course, to go and define, add a couple of lines of code for each and every function, and to add this logic, right? So I could go here and add here some like print line and to write some interesting message, etc., etc. But this is not the best solution. First of all, it is a lot of code duplication because the message will actually be the same. And the second reason is that I don't really want to change the content of my functions. I don't really want to rewrite the existing functions. Okay, think about it. I have 4 functions, but maybe I could have like 40 functions. I don't want to go into each and every function and to rewrite it. Now, Python Decorator allows me to perform this task of manipulating my existing functions a little bit in the convenient way. And let me show how Decorator does it. Now, for now, you will not understand what is it. I just want you to see the simple syntax. But I promise you that by the end of this video, you will understand everything. So look, I defined some kind of interesting creature called Decorator. And the syntax to write it will be like this, okay? And I called my decorator a greeting decorator. So now look, when I will come and I will put just this one line of code before each and every one of these functions, the behavior of each of these functions will change. And in order to show you how it will change, let me just run the same code again here. So look, do you see? Now I have this beautiful welcome message. Okay, welcome to function capitalize. And then I've got like the same message I saw before that asks me to insert some text to capitalize. And then it prints me the capitalized text. And then I've got this goodbye message. Okay. Let me just show you that the same happens, for example, with convert from Fahrenheit function. So look, if now I will run my file again, you see I have again the same message, hello and welcome, except for the fact that the name of the function has changed. And now I can enter, let's say, some temperature in Fahrenheit, and it will convert it to Celsius, and then I'll get this goodbye message. Now look, what happened here is a kind of magic, right? Because I didn't change the content of the functions themselves. I just added some string, right? Some identifier before the definition of the function, and the behavior of the functions has changed. So what we are going to do now is we are going to understand what is this creature, how it works, and how to write one. Okay, so let's start from the beginning. And just before we can really go and write our first decorator, there are a couple of topics we need to make sure you understand. So I will now run some code snippets inside this nice tool, which is called Google Colab. If you don't know what is it, just check it out. This is a Python notebook which runs on cloud, and you can use it as you like. You can just if you just have a Google account, you can have one for free. It allows you to write Python code. It also allows you to use GPU if you need one. So worth checking it out. But let's go to our business. So in order for you to understand what Decorator is, I would like, first of all, to make sure that we really understand what function is. And the first thing I want you to know is that function is an object. And let me show you. As you can see here, I defined some very simple function that is called greet. And the only thing that this function is doing is it just prints hello all text. So let me just run this code cell here. So the function is now defined. And I suppose that you know that we can call this function, right? So we can run it by providing its identifier, right? This thing here, greet, is called an identifier. So I can provide the identifier and put these brackets. And then if I will run this, that the next thing that will happen is that actually the code that defined inside this function will run. So that's why we see this hello all printed on the screen. But in addition of being able to call a function, as I said, function is an object. So we can treat this identifier like any usual object or variable in Python. And let's see. So for example, if I will write this grid identifier without the brackets, right? I can, for example, get the type of the grid object. And let's run it. So if we run it, we will see that grid is an object, right? A class of type function. And if this is an object, then I can also maybe get some attributes for this object. And just as a nice bonus, you can see that functions have various attributes. So for example, if I will access them, you will see that the attribute, built-in attribute name, actually returns me the name of the function. And the built-in attribute doc for documentation returns me the documentation of this function. Now, where does it take it? Look, just here, right? I defined here some documentation string for my function. And you also have this code attribute for the function. And this attribute, you can see, just defines me some address in my memory where the function code is actually defined. And it also provides me some information about the file in which the function is stored. Okay, so again, just pay attention that when we want to treat our function as an object, we don't put the brackets after the function identifier, right? And when we want to run the function to call it, we actually put these brackets here. Okay, so if function is just an object like any other object or variable, then in addition to calling it and printing some attributes of it, we can also pass it as a parameter to another function. And let's see an example. Look, I defined here a new function called wrapper, and it receives as parameter some object, which is called other function. So you can understand from the name of this variable that the parameter that is being provided here is a function by itself. And what this wrapper function is doing, it prints some message. Okay, particularly it prints the function that it received as parameter. And then my wrapper calls, okay, it makes a call to the function that was received as a parameter. Let's try to run it. So look, what happens here is that now I'm calling a wrapper function defined here, and I provide it as a parameter my grid function that has been defined before, right, at the first cell, right here. Okay, so let's run it. Okay, sorry, I just forgot to run the definition of the function. Now let's run it again. And we see here, okay, we see this message that is written inside the wrapper function. This is exactly this one. And then you see this hello all string, and it comes exactly from wrapper calling my grid function. Okay, so we saw that the function can be passed as a parameter to another function. And now let's just go one tiny step forward before we really get to the decorators. And let's make our code a bit more complex. And let me show you that function can also create another function, and it can return it as a return value, right? Since function is an object, so any object can be returned from any function. And let's see an example. So we are creating a new function that is called createQuote. It has no parameters, it receives no parameters, and two only things this createQuote function is doing are as follows. So first of all, it prints some message, And then look here. I have a definition of a totally new function inside my create quote function. You see? Now, as the function name states, it actually just prints some nice quote by John Quincy Adams that says, "Try and fail, but don't fail to try." And after we create this function inside another function, we return it. You see, this is the same display quote that has been created here. Now, I understand that I know that it could look a bit weird, but think about it like this. Defining this function and returning it from the outer function is quite like if I would create some variable here. Let's say I would call it like num. I will provide it a value here, and then I could just write something like return num. Okay, so think about it. I created a variable or an object, an integer object, and I returned it from my function. The same happened here, right? With one small difference, that the object that I created here, it wasn't an integer, it wasn't a number, it was a function. So just like I could create here some number and return it, I can also create here a function and return it. That's all. So let me just delete this num. And let's run this code cell. Great. Now let's see how we can run this create quote function. So first of all, pay attention. When I call this create quote function, which is this one, what do you expect to get as a return value from it? And the return value I expect to get is of type function, right? Because this create quote function receives no parameters and returns one value, which type is function. That's why if I will write this line of code, my new variable created function will contain a function object. Let me run it and show you. Okay, so you see, first of all, you see this message creating a function that will print a quote, which comes from here, right? Because I just called this create quote function. And the next line you see here is actually the display of what created function is. And you see that this created function is a function object here, right? By the way, you can also see that it was created inside create quote. Okay? Nice. So we saw it. And now, since this created function variable is a function itself, I can call it, right? So there is absolutely no problem in running this line of code, created function, and putting these brackets here. Let's look. Okay, so now you see this beautiful quote printed in here. So now, after we saw all these properties of functions, let's move on to writing our first decorator. So, what decorator is? And in fact, decorator is a function that receives another function as parameter. It creates some inner function inside it and returns this created function. Now, what exactly this decorator is doing? So look, my decorator receives some function. Then inside it creates an inner function which I like to call a wrapper function. And this wrapper function, what it does in our case, right, it prints this beautiful hello welcome message, just like we saw at the beginning. Then this wrapper function calls, right, or runs this function that was received as a parameter. And then after this other function finishes running, it just prints the last beautiful goodbye message. Let me go back to the PyCharm here. And I want to show you that I defined this decorator right here. You see, just a moment here. This is the same greeting decorator that you saw in Colab. And look what's happening here. So, when I go and I define this notation of greeting decorator before the definition of the function, what Python is actually doing is as follows. It loads this file, for example, this module, various function. It performs this import and it performs this import, and then it comes to this function definition. Now, when Python sees a function definition that does not have any decorator defined before, like this, the regular case, in general, it goes and stores somewhere in its memory the fact that factorial is an kind of alias, right, to these lines of code. So the Python interpreter knows that each time then that someone will write something like this, factorial, right? Factorial, it will know that it should just go and run these 3 lines of code. Now, what happens when I have a function definition when there is a greeting decorator comes before it? So my Python interpreter continues loading the file. It sees this definition. And then it says, okay, I see here a new function identifier, which is called capitalize. Now, since there is a decorator defined before, I cannot just go and say that capitalize is actually a kind of alias to these 2 lines of code. I should, first of all, go and do this one. I call this greeting decorator function, and I pass it as parameter my capitalize function. Okay? And the result of this and the return value of this function will be stored back inside the capitalize. Now let's see what actually happens when I run this thing. And in order to see it, let's go to my decorators code. So here, let's say I have this greeting decorator and my capitalize function is now passed here. So what the greeting decorator does? It defines a wrapper function, this one, and what this function is doing. So first of all, it prints this beautiful hello and welcome message. Then I remind you that other function is actually my capitalize function. So the next thing that happens is that the code of my capitalize function is running, okay, which is exactly this code. And then after my capitalize function finishes running, the greeting func displays the goodbye message. Now all this wrapper function is returned from the greeting decorator, and that's why when this line of code is run by Python interpreter, the capitalize now stores a new function, right? It does not start this original capitalize function, but it actually stores this inner function. And the actual effect of doing this is changing a little bit a behavior of our original function. Now let's just run it again so we could see how it works. Let me just delete this kind of pseudocode here. Okay, let's run. Okay, so please note that now my convert from Fahrenheit function, it's not this function, okay? It's this function. And this function says, first of all, write hello and welcome. This is what exactly is being done here. Then, by this line, it says, okay, now run the original convert from Fahrenheit function. And this original function is exactly performs this input operation, and then it performs this calculation, and then it prints the result. So here it is. Let me enter it again. And then after convert from Fahrenheit finishes running, the last thing that has to be done is printing of this goodbye message. And here it comes here. Okay? So what you've seen now is the actual behavior of decorators. You also saw, and together with me, you wrote your first decorator. I really encourage you not to stop here and to continue watching the next videos. In addition, of course, you can find all the code presented here in the comments of this video. So download it, try to run it. It will help you to understand better how exactly decorators work. Congratulations! You implemented your first Python decorator. I hope you enjoyed it, and I hope you learned a bit of new topics. I think that now you understand that decorator is kind of wrapper function that receives a base function and updates its behavior a little bit. Now, I encourage you not to stop here and continue watching the next video, because in the next video we will see even more complex examples for decorators. We will implement more decorators, and we will also see how to write decorators that work on functions that receive parameters and return values. We will also see how to implement decorators inside a class. So, let's go!